SY143-2A, my metric number 2020990293.
Hi and Assalamualaikum. My name is FAIZATUL binti KHAIROL AMIR RASHID. I'm from CS142A. Metric number 2020984283.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is SYAHMI bin Muhammad SAHIDI. My metric number 2020950355.
What is differentiation? In mathematics, process of finding the derivative or rate of change of a function. Differentiation is the action of computing a derivative. The derivative of a function y equal fx of a variable x is a measure of the rate at which the value y of the function changes with respect to the change of the variable x. It is called the derivative of f with respect to x. If x and y are real numbers, and if the graph of f is plotted against x, the derivative is the slope of this graph at each point. Why we use differentiation? Applied maximum and minimum is related to our question assignment. The process of finding maximum or minimum value is called optimization and normally applied in industry world. For example, a business person wants to minimize costs and minimize profit. A traveler wants to minimize transportation time. A manufacturer wants to find the least amount of material to make a particular object.
Problem statement. The process to finding maximum or minimum value. Step 1. Understand the problem. In this equation, we want to determine the dimension of the field that will maximize the enclosed area. Step 2. Draw the diagram. Step 3. Introduce notation. Assign a symbol to a quantity that is to be maximized or minimized. Let the width be y and let the length be x. Step 4. Use the information given to find relationship in the form of equation. Differentiate to find the value of x. Do the first derivative equal 0 to solve y. Substitute y in the formula of area. We have two methods for this equation. Method 1. Use calculus on the formula of area. Multiply out a formula before doing the derivative. Method 2. Use graphing calculator to graph the function area. Use the calculator's maximizing command to locate the maximum value of the curve.
A quick sketch of the problem. So we are told that we have 700 ringgit to spend. So the cost of the material will be constant for this problem. From this sketch we get 700 equal to 20y plus 9x. Next, we are being asked to maximize the area. So that the equation area equal to x times y. Next, we are solved for y. So, from the equation, we get 700 equal to 20y plus 9x. So, forget the y, we must divide 20 by this equation. 700 divided by 20 minus 9 divided by 20s equal to 1. From this equation, we get the answer 35 minus 9 over 20s equal to 1. So, we are plugging the equation into the formula of area. So, area equal to x times 35 minus 9 over 20s. So, the answer is 35x equal to 9 over 20x squared. Next step, we are finding the critical point by use derivative. From the equation, we derivative the equation, we get the answer 35 minus 9 over 10x. From the equation, we can find the x. So, 35 minus 9 over 10s equal to 0. So, the answer for s is 350 over 9. Next step, we use the second derivative. So, the answer for the second derivative is negative 9 over 10. The second derivative always negative, so area will concave down. The critical point in step before this must be the relative maximum, thus must be the value that gives a maximum area. So for the last step, let's finish the problem by the second dimension. So y equal to 35 minus 9 over 20 times 350 over 9 equal to, we get the answer is 35 over 2. So from the equation, we find the y is 35 over 2, s is 350 over 9. So y and s are the final dimension. Thank you.
In conclusion, we can conclude that differentiation is used in almost everything. So, differentiation is used to find change of one thing with respect to other.